Okay, so I'm gonna do 25 next, which is the same idea as the last one that I just did. In this case, we have two graphs. This one is a cubic function. Notice how I can tell. Okay, this one right here is a cube root function. Creates an S, but it's stretched out, so it looks like it's gonna be flat towards its ends. This one is a cubic function. So it looks like an S, but it's stretched out that way. So it looks like it's going to end up being almost vertical towards its end. So that's the difference between them. The other one was cube root. This one is cubic, meaning to the power of 3. But we're going to solve it the same way we solved the other ones, by finding B, H, A, and K. B, H, A, K, X, G of X. Same thing. In this case, you're looking for the point of symmetry right there. That is your HK. So that is +1, -4. That's HK. So H is 1, K is -4. Using those two, X and G of X is another point. I'm going to use this one right here, which is 0, -2, as my X, G of X. 0, -2. That is X and G of X. So X is 0. G of X is -2. Next, decide if I want to use B or A. So same thing. Notice that the difference between the points got stretched vertically. They should be in a straight line like this, but they are stretched out, so there's a vertical distance between them that is not 1. So that would be A. We're going to look for A, not for B. Using those and plugging them all in into my general form. We're looking for A, so leave the A there. X minus H cubed plus K, right? This is a cubic function, so that's the one we're going to use. Plug in your values. -2 equals A. X, which is 0, minus H, which is 1, cubed, plus K, which is -4. We're going to solve this. 0 minus 1 is -1. Cubed minus 4. Let's keep going here. -1 cubed is just -1, so -1 A times -1 is just -1A, or -A, minus 4. Okay, almost there. I'm going to add 4. That's going to be 2 equals -A, so finally A is equal to -2 because I divide by -1 to cancel. There it is. It's -2. Plug those in into your general form except for X and G of X, and you are done. So it's going to look like this. G of X is equal to A, -2, times X minus H, X minus 1, cubed, plus K, minus 4. Minus 4. There you go. That is the function for that graph. Okay, the next one in the same problem, number 25, but now I'm looking at this one right here. This is not a cubic or a cube root or a square root or a quadratic function. This is one of those polynomial functions. So what we're going to use to find the function for this one is identify the x-intercepts and identify the end behavior, and that's pretty much going to be it. Okay, so this is what I mean. It's going to look like this. F of x for this one, there's going to be parentheses, 1 for each x-intercept. I see 3. 1, 2, 3. So each one of those will give me an x-intercept. So for example, this -2 gives me a factor of x plus 2. Right? Remember, whatever the x-intercept is, the factor is the opposite. Or if the factor is x plus 2, the x-intercept is -2. So it goes back and forth. This is 1, so that'll be x minus 1. The next one is +6, so that would be x minus 6. Next, you need to identify what the A value will be. There has to be an A value here that I forgot to write. And in all of these problems, the only options that you have are 1 or -1. That's it. Just 1 or -1. Look at the right side of the graph and identify what's happening to it. Is it increasing or decreasing? It's increasing on the right side, right? Since it's increasing on the right, A must be positive, so it's 1. f of x equals 1 times x plus 2 times x minus 1 times x minus 6. Next, what you need to do is go look through here and see if any of these x-intercepts are crossing or tangent. What you care about is the tangent ones. If you see any tangent ones, that means that the factor has to be squared. So for example here, this one's crossing, this one's tangent, this one's crossing. See how the graph is crossing right through? So for the tangent one, that is 1. 1 is this one right here. So what you got to do is you got to square it. Because tangent means that the power is even. So we need an even power right there, which is 2. Could also be 4 for all we know. Okay, but we're going to make the assumption that it's the smallest possible value. So there you go. That is it. Since the positive 1 is in the front, we don't really have to write it because it doesn't do anything. But that would be your function. Alright, I'm going to skip 26 through 32. It's the describe the transformation of the graph. I think you guys can handle it. Just as a hint, what you guys need to do, find B, H, A, and K for each one. And then from that, tell me what happened to the graph. So just a quick example. I'm not going to solve it or write it. But this one, K, is negative 3. So that's a shift down of 3. A, this is A, is negative 2/3. So since it's negative, that's a reflection across the x-axis. And 2 over 3 is a number that is smaller than 1. So it's also a compression by a factor of 2/3. And you got to do that to all of these, right? Find B, H, A, and K, and then tell me what it means. Go back and look at your notes of where we wrote all of those down so you guys can remember, memorize, and try to work them out. All right, let's move on to 34. 34, f of x equals x minus 3 squared times x plus 4 squared. So the steps are identify the domain and the range, find the x and the y-intercepts, does the graph cross or is it tangent at the x-intercepts, then graph the function. Okay, so I'm going to start by finding the x-intercepts. That is the easiest thing I can think of right now. So find the x-intercepts. The x-intercepts, you guys should be able to see them now, is positive 3 and negative 4. So x-intercepts are positive 3 and negative 4. That's where it's going to cross or touch the x-axis. Y-intercepts come from the same thing. To find the y-intercepts, they're not obvious. You have to plug in 0 for x. And you're going to find the y-intercept. There should only be one, by the way. There shouldn't be more than one y-intercept because that would make it not a function. So plug in 0 for x and see what you get. So basically, 0 here, 0 here. See what you get. Let's use mental math. I think we can do this. 0 minus 3 is negative 3. Square it, it's 9. This is 9. In this one, 0 plus 4 is 4. Square it is 16. So it's 9 times 16. Which is 144. So the y-intercept is 144. Then it says to graph it and find the domain and the range. Does it cross or is it tangent? So that's what we're going to say. So for this one, you can easily tell if it's going to cross or it's going to be tangent. We're going to write it for x equals 3. Look at x equals 3 right here. See the power? It's even. Even means tangent. Odd means crosses. So not that the number is even, but the power, the multiplicity is what we say, is even. So this one's going to be tangent. X equals negative 4, the other x-intercept, look at the power, also even, so it's also going to be tangent. So it's going to be tangent at both of those points. Okay, identify the end behavior. To identify the end behavior, you look at the first coefficient of each factor and multiply them times each other. 1 times 1 is just 1. Positive or negative? Positive, right? So it's 1 x to the, look at how I find the power of x. This is x squared and this is x squared. So together they make x to the 4th. That's going to tell you the end behavior. Look at your a value. Positive or negative? Positive. That means that on the right side, it goes up. Look at the power. Even. So positive a, that means up. Even means that they're both the same. This one does not tell you what each one does. It tells you how they're related to each other. So this one tells you if it's even, that they're both the same. If it's odd, that they're opposites of each other. So if that one's up, this one's down, and so on. Since this is even, that means that the left side also goes up. That's the end behavior. That's what it looks like. Did we have to write that one down? No, we don't have to write it, but we're going to use it to graph it. So once we have that, this is what the graph looks like. Here's my x-axis, my y-axis. Find the two x-intercepts. 1, 2, 3. Here's 3. -4. 1, 2, 3, 4. -4. Those are the two x-intercepts. I know the end behavior is on the right, it's going up. On the left, it's also going up. And according to my writing here, at x equals 3, it's tangent, and at -4, it's also tangent. So at both of them, it's going to be tangent. So that means that it's not actually going to cross through. It's just going to touch it, go back up, like a little mini parabola, come back down, and do the same thing there. Touch it and go back up. And that is your graph. We can identify the domain very easily. Since it's going to keep going to the left forever and to the right forever, the domain is all real numbers. The range is not all real numbers, because as you can see, the graph does not exist down here. The lowest point is 0. For both of those, the lowest point is 0. So the range is all the values of y that are greater than or equal to 0, because it starts existing at 0 and then it only exists above that. So greater than or equal to 0. And that's it. Okay, 35, same idea as the last one. I'm going to start by finding the x-intercepts. So x-intercepts come from the factors. I see here it's obvious that it's 5, right? This one also gives you an x-intercept. It's 0. Okay, anytime you see a single x without being added or subtracted to anything, that is really x squared minus 0. So it's x equals 0. So the two x-intercepts are 0 and 5. Y-intercepts. Remember what I said about y-intercepts? Just plug in 0 for x and see what you get. So if I plug in 0 here and 0 here, what do I get at the end? You're going to get 0 times -5, which is 0. So the y-intercept is 0. Okay, so the y-intercept is 0. The next thing I'm going to do is identify the end behavior. And oh no, first we're going to find out if it's tangent or it crosses at each of the x-intercepts. So at x equals 0, right, that's one of my x-intercepts. Look here where it came from. It came from here. The power is even, so that's going to be tangent. At x equals 5, look where it came from right here. The power is odd. That's power is 1, right? So that's going to cross. Next, I'm going to identify the end behavior so that I can graph it. So I know that. Those are the x-intercepts. The end behavior, remember what I said? Look at the a value for each one, the leading coefficient. It's 1 times 1, so it's just 1. X to the, this is x squared and this is x to the 1. So together they make x cubed. According to that end behavior, a is positive, right? Positive a, that means that it's going to go up on the right side. N, the power, is odd, which means that they're going to be opposites of each other. If that one is up, this one is down. So that's what it's going to look like. I can now graph it. Here's my x-axis, here's my y-axis. At x equals 0, there's a 0 there, and there's another one at 5. 2, 3, 4, 5, right here. Those are the two zeros that we have, the two x-intercepts that we have. The end behavior is down on the left, up on the right, like that. And then we identify that it's at 0, it's supposed to be tangent. So I'm going to draw my arrow towards 0, but I'm not going to cross through. I'm going to make it tangent, come back down. Then draw it through towards that one, and it's not going to be tangent, it's going to cross right through. There you go. Finally, identify the domain and the range. The domain and the range are both very, very easy on this one. if you notice, for domain, that means what could x be? What are the possible values of x? It's going to keep going to the left forever. It's going to keep going to the right forever. X is all real numbers. The domain is all real numbers. And that's how we write all real numbers. Y, the range, same thing. It's going to keep going down forever, up forever. So y is also, the domain is also all real numbers. Like that. And you're done. Okay, 37. Describe the transformation of the graph in reference to the parent graph. Do not find or show any equations, functions of the graphs. So it's asking you, can you tell what the transformations were without having to look at the original table, find a new table, without having to find B, H, A, and K, and so on? Can you tell what it's supposed to be? Okay, so in order to do that, you should be familiar with what the parent function looks like. So that's what I'm going to do. The parent function, I know for this one, this is something that you should know, you have it on your notes, looks like this. Oops. It's -1, -1, 0, 0, 1, 1. Those are my 3 points that are in the middle. It's also -2, -8, and 2, 8, but those are way up there. So all I care about is those 3. And it's increasing from left to right. So just comparing this, the parent, to the other one, I can now tell what happened. First, it got flipped around. You see how it's going, it's decreasing, but it was supposed to be increasing. So that's a reflection. What type of reflection? It's either one. If I reflect horizontally, it's going to look like this. If I reflect vertically, it's going to look like this. Alright, my alarm just went off. Let's keep going. So I can see that it flipped around. So it's either A or B. It's either type of reflection. Okay, whichever one you choose. I'm going to choose A. A is negative because there's a reflection. Okay, negative something, just negative for now because maybe there's a stretch. That's what I'm looking for next. Look at the difference between the points. In the original, the vertical difference between them is 1. The horizontal distance between them is 1, right? Vertical distance between them is 1. The horizontal distance between them is also 1. In the new one, the horizontal distance between them is still 1, right? From this one to this one is just 1 unit. From this one to this one is just 1 unit, horizontally. But vertically, the distance changed by 2. See that? It used to be a distance of 1 vertically, but now it's a distance of 2. That is a vertical stretch by a factor of 2. That's what that represents. Okay, so once again, let me show you guys how we got that. The horizontal distance between the original points is 1. The horizontal distance between the final points is also 1. So that didn't change. No vertical stretch or compression. The vertical distance between the original points is 1, but the vertical distance between the final points is 2. So that is a vertical stretch of -2. All right. Also, we said negative because it got flipped around, right? The next thing to figure out is H and K, and that comes from that center point. You can easily find those center point, which is 1, -4, the point of symmetry. And that's your H and your K. H is -1, K is -4. So using those 3, now you can describe it. It's a vertical stretch by a factor of 2. Stretch by a factor of 2. It's a reflection. What type of reflection? A vertical reflection, right? Because it's A. Vertical reflection means a reflection over the x-axis. Reflection over the x-axis. And then H is -1. That means a shift left 1. H is not -1. I got that wrong. Hopefully you guys caught that when I wrote it down. H is +1, right? I just plotted that point incorrectly. It's 1, -4, not -1, -4. So this is 1, not -1. Alright, so that changes. It's not a shift to the left, it's a shift to the right. Right 1. And that makes more sense, right? You can look at the graph. It did not move left, it moved to the right. And finally, the k equals -4, that one is correct, is a shift down. A translation, really, 4 units. And that is the transformation. Okay, for 37, we're going to do the same thing. What I'm going to do first is just put the parent function here. 0, 0, 1, 1, 4, 2. I know that one. Look at your notes. That is the parent function for that one. It's a square root function. Then I can start looking for different things that happen. The easiest thing, actually, what we should have done in the last one is identify h and k. That should be the easiest thing. So let's do that first in this one. H and k comes from this point, which is -5, 3. That's your h and k. H is -5, k is 3. Next, look for stretches or reflections. Okay, once again, the same way. Look, the distance between these two original points is 1. Horizontally, it's just 1. Vertically, it's also just 1. But in this one, horizontally is still 1, but vertically, it's 2. So it got stretched vertically by a factor of 2. Which parameter stretches vertically? A. A is 2. Using that, I can now write my description. This right here means shift left by a factor of -5. We don't have to say by a factor of. Just shift left 5 units. This one right here means shift up 3 units. And this one right here says vertical stretch by a factor of 2. There you go. And by the way, we should always, I didn't in this case, but we should always use A and B first. Describe those two things first before H and K. Because stretches are multiplications and those should be first. Okay, this is the last one that I'll be doing on this review. 38. Write the transformation of the function f of x equals cube root of x with a vertical compression. Okay, vertical compression. Right away I think A. By a factor of 1/4. So A equals 1/4. And the reason why they use compression instead of stretch is because the factor is a number smaller than 1. So that is a compression. Translate it 5 units left. That's H. Left. The one that shifts things to the left is H. H is -5 because it's to the left. If it said right, I would put +5. And 2 units up, that's K. K is 2. Using those 3, write the transformation. So write this using these parameters in there. So it's going to look like this. F of x. You know what? F of x is the original, so let's actually use g of x. G of x equals a, 1/4, right? A is always in front, times the cube root of, in there, we're going to put x minus h. So it's x minus -5, so +5. And then the k always goes outside at the end by itself. There it is. Looking at that, you can easily see that a is 1/4, h is -5, k is 2, which is exactly what they told me there. And you're done.